Hello and welcome to another Smooth Economics video. In this video we will be looking at the algebra of marginal revenue, and this video forms part of our wider revenue topic, although it perhaps goes a bit beyond the minimum requirements of the A-level course. So, without further ado, the algebra of marginal revenue. To recap, marginal revenue then, the addition to total revenue from selling one more unit of output. Remember, this marginal term refers to the incremental change to one variable, in this case the change to total revenue, from an additional unit to another, in this case an additional unit of output sold. Our equation for marginal revenue equals change in total revenue over change in Q, where these deltas, these triangle symbols, denote change in a variable. Marginal revenue is the gradient function of the total revenue curve. It is the differential of total revenue with respect to quantity. So, to recap the diagram, the marginal revenue curve is always below the demand curve when the demand curve is downward sloping. Our blue MR curve is always below our red AR curve. For straight line demand curves, the marginal revenue curve has the same intercept on the p-axis, same intercept there as the demand curve, but it is twice as steep. The quantity where MR is equal to 0 is half the quantity where AR is equal to 0, because the MR curve is twice as steep, and that's what we'll be proving today. So, prove that MR is twice as steep as AR. Since the marginal revenue is the derivative of total revenue, i.e. it tells us the change in total revenue from increasing quantity, we can construct the marginal revenue curve by calculating total revenue as a function of quantity and then taking the derivative. So to calculate total revenue, we first start by solving the demand curve for price rather than quantity. And this formulation is referred to as the inverse demand curve. So, demand functions, quantity demanded is a function of price, in this case QD equals 40 minus 5 times the price. Rearranging this to get a function of price, P equals 8 minus 1/5 QD, a simple rearrangement. The reason we've rearranged this equation now is of the form y equals mx plus c, or the way I've written it, c plus mx, because remember our x-axis in our diagrams at the moment is quantity, our y-axis is price. So it's a straight line equation telling us about our demand curve, our AR curve. We can then plug this inverse demand curve into the total revenue formula. We know total revenue equals price times quantity. We also know from looking here, price in this case is equal to 8 minus 1/5 QD. So by substituting that in for price, we get total revenue equals 8Q minus 1/5 Q squared. As stated before, the marginal revenue is then calculated by taking the derivative of total revenue with respect to quantity. So marginal revenue equals DTR over DQ equals 8 minus 2/5 of Q. Some simple GCSE calculus for you there. So let's compare these two lines, our MR curve and our inverse demand function. We notice firstly that the coefficient on Q is twice as large in the MR function as it is in the inverse demand curve. That tells us that the gradient of the MR curve is twice as steep. Furthermore, we know that the constant in both curves is 8. That tells us they both start on the same place on our p-axis, which is our y-axis in our diagrams at the moment. So MR and AR start from the same point on the price axis, and MR is twice as steep. Thanks for watching this Smooth Economics video. Don't forget to subscribe to our channel. You can also visit our website, www.smootheconomics.co.uk. Here you can find more resources, extension materials, details of upcoming courses, competitions, and much more. We are also on social media. Follow us on Instagram, Twitter, and Facebook with the handle at Smooth Economics. Thanks again for watching, and we hope that you continue to enjoy our videos into the future.